Hello, my name is Rob Reynolds. Welcome to Math 073, where today we're going to be looking at our fifth section, equivalent algebraic expressions, and at the very end of this we're going to look at our first factoring lesson. We're only going to look at greatest common factors, GCFs, to begin with. So again, to recap, we're going to be looking at equivalent expressions. Remember, no equations yet. We're going to be exploring the commutative and associative laws and look at the distributive laws. Two expressions that have the same value for all allowable replacements are called equivalent expressions. For example, if I have 3x, that's equivalent to 2x plus x, because no matter what you let x be, the allowable replacements are your x values, and no matter what you let x be, the left side will always equal the right side. So this is an expression, this is an expression, this whole thing is called an equation, but this expression is equal to this expression. So they say complete the table by evaluating each of the expressions. So the first one says let's let -2, or let's let x be -2. So each time you see an x, let's plug in -2 plus 2 times -2, which is -2 minus 4, or -6. And it looks like we get the same answer here. 3 times -2 is also -6. But over here, it's 8 times -2, but be careful, this is minus, and I would recommend every time you see an x, replace it with parentheses, and then in the parentheses we put this value, -2. And if you remember from a previous lesson, two negatives make the positive here when you're subtracting, so this is actually -16 plus 2, or a whopping -14. So our answers are -6, -6, -14, and it looks like the author agrees with us here. -6, -6, and -14, and you're welcome to finish up that chart if you would like. There was a couple other problems. You need to now redo this problem for 5 and 0. Moving on, I've got, again, equivalent expressions. X plus 2x is the same thing as equivalent. Is equal to 3x. The expressions x plus 2x and 8x minus x are not equivalent, because if you were to let x be 5, over here you would get a different answer than if you let x be 5 here. The property of 1 says, the property of 1 says you can multiply by 1, so 5 times 1, and get itself back. So it doesn't matter if you do 1 times a or a times 1. Either way, the answer is just whatever you're multiplying the 1 by. So why is this helpful? Because you can multiply 3 times any number. We could pick a 2, we could pick a 5, 3 times 5, we could pick 3 times 4. So if you multiply the numerator by 4, multiply the denominator by 4, but as long as it's a 1, we're going to get an equivalent fraction. So in this case, let's multiply by 2x. So 3 times the 2x is going to give me this 6x. And believe it or not, usually we don't do this, but 3/5 is equivalent to 6x over 10x. It reduces. So that would be an equivalent fraction as well. Normally we would take 3/5 and maybe multiply by 4, the numerator and the denominator, and end up with something like 12/20, and say 12/20 is equivalent to 3/5. It reduces, but so is 6x divided by 10x. It also reduces to 3/5. And here's the author explaining that same thing. So now we can go backwards and simplify. So any numerator divided by a denominator we can cancel. X divided by x is 1, and I'm left with just 7/9 here. So that's what we're doing. Just they go through a little bit more complicated, but they get 7/9 as well. So let's see, the y's cancel here. 24 divided by 16, if we divide top and bottom by 8, or multiply by 1/8 over 1/8, same property, we get -3/2. The easiest way to kind of talk through that. So they're multiplying by 8y over 8y here, which is equivalent to my 1, to make it the 1 property. Evaluating says, first of all, we're going to let x be 5, so this would be 5 plus the 8, which is 13. Notice that that's the same thing as 8 plus 5 is also 13. So it doesn't matter which way we add, or the order that we add these things in, and that's called the commutative property. When you commute, you move from home to school, so that's the commutative property. You can move these letters around. So it doesn't matter. 5 times 4 is the same thing as 4 times 5. They are equivalent expressions. That only works for addition and multiplication. You cannot do that for subtraction. For example, we know 5 minus 4 does not equal 4 minus 5. And it does not work for division either. 4 eighths does not equal 8 fourths. So be careful. You can only use the commutative for addition and multiplication for your commutatives. So next we have the associative. The associative means we keep the order the same. So notice we've got A, B, and C. So commutative moves the order around. Associative, we keep A, B, and C the same, but notice what did they change? Instead of grouping, so associating the B and the C together, they've associated the A and the B together. So that's the associative property. And again, we get something very equivalent. It doesn't matter if you associate the 8 and the 5 first to get the 13 and then add it to the 4, or you can associate the 4 and the 8, add it to the 5. Either way, we still get 17 for our final answer. So the associative property is telling you you can group these in different orders and still end up with the same answer. Let's try an example. A is 7, B is 4, and C is 2. So let's plug these in. So instead of A times B plus C, we would have 7 times 4 times 2, which is 7 times 8. 56. And similarly over here, now we've got the A term is 7 times my B term 4 times the C. So now we have 28 times 2, which is still 56. So again, we're proving the associative laws. Both answers give me 28. So again, the order is going to stay the same for the associative. You don't mix up A, B, and C. The order stays the same. The commutative and the associative laws can be used, three different ways. So let's see. Let's group this differently. I'll keep the order the same. X, 8, and Y in the same order, but I could group them differently. So that's one way that I could write this differently. I could, flip this. X plus, here's the commutative, Y plus 8, and I could say Y plus 8 plus X. Oh my gosh, I could put 8 first. 8 plus X plus Y. All sorts of ways to use the commutative. So here's what the author chose, but there's certainly more than 3 correct answers here. Evaluating, again, letting X be 4 and Y be 5, I would say 4 plus 5, which is 9, and 8 times 9 is 72. Notice it's the same thing. 8 times the 4 plus 8 times the 5. This is 32 and 40, and looks like I still get 72 for an answer. So I think what they're doing is they're building you up for another property called the distributive property. So they're proving that this is equal or equivalent to 8x plus 8y. So notice we can distribute this 8 and do 8 times 4 and then do the 8 times the 5 and end up with the same answer. So here comes the distributive. So we've got commutative, you change the orders, associative, you group it, and distributive property, you distribute the A to the first term and A to the second term. So there's your distributive property. A times the B and then A times the C. Using the distributive property, well, actually, it wants you to plug in some numbers here first, I guess. So plug in the 42 and the 78. I'm going to skip this example. You could either subtract it and get the negative 36 or negative 18, or you could actually distribute. 1/2 of the 42 is 21. 1/2 of the 78 is 39. And notice, again, these are equivalent expressions. So again, the distributive law of multiplication, there's the formula for it. We're going to look a little bit today to end this video with the greatest common factor for factoring only. So if I have something like 3x plus 6, The greatest common factor there is 3. So I'm going to ask you to divide each term by 3. And what's left is x plus 2. So that's called greatest common factor. So first of all, we need to look at what terms are. And terms are separated by addition and subtraction. So I would say 3x looks like a term. This is not 4y. It's actually a negative 4y, which is the term. And remember, this is not a negative. This is a minus, which is the same in my book. But if I were to ask for the term, I would say negative 2z is the term. I don't like what this author said. That's why I have this sad face. Why? Because they're doing plus these negatives. But maybe that drives the point home that the term is actually the negative 4y and it's not the positive 4y. But I'm not a big fan of double signs. So if I were to ask for factors of 6, I would say 1 and 6 and 2 and 3. Factors are things that we multiply together to get the answer. So if I were to ask for the GCF of this guy, I would say 8, because each term divides by 8, and that leaves me with x plus y. So an example of this, each term, the greatest common factor, what goes into 9 and 27, would be 9. And literally what's happening, you don't need to write this step, but what's happening is you're dividing by this red 9 to both terms. Every term gets divided by 9, leaving you with x, because the 9's cancel here, plus 3. So we factor out a 9 by finding the greatest common factor between 9 and 27, which is 9. And here's how the author explains it. Here, what's common between these two terms? Well, there's only 2 terms because there's my only addition and subtraction, which separates terms. It looks like p is what's common, so I'm going to factor out a p. Again, you don't need to write this red step, but that's literally what's happening. You're dividing each term by p, so be careful. This is actually a 1 right here, plus this p cancels, and it's rt. So this one's tricky because this p term actually cancels, but there's not a 0 there. P divided by p, remember, is a 1, so you need a placeholder here. You can check these very easily because all you need to do is go back and distribute. So p times the 1 plus p times rt better give me back the original, and it does. Here's how the author explained that. I hope this video was helpful. If you have questions, feel free to give me an email.